Hello, this is Elliott Zaresky-Williams, CTO and co-founder of Neurales. So today we'll be going over our second demo of our app, Neurales, and today we'll be talking about regression, whereas demo 1 was talking about classification. So what exactly is regression? Regression is really when we train a model to predict, certain numeric values based on data. One example of this is just temperature on a given day, based on something like, atmospheric pressure or some other related quantities. And so Neurales lets you do this for CSV files, pretty much data in tabular format, and never forget that you can always save Excel files as CSVs and import them over to Neurales. And soon Neurales will actually be able to offer regression for image data. And this would be, this example that could be predicting someone's age from a photo. And then this example will be specifically using historical Bitcoin prices. Our data set will be historical Bitcoin prices from 2019 through the first day of 2020. And so one thing I want to talk about before we get started is that feature analysis is a bit buggy for regression. This is where we predict how important our predicted variable is, how important each feature is in the final prediction. And this is a buggy for regression, unfortunately, but this will be fixed in the next update. And also, our manifold plots that we saw in the first demo are going to be, plotting more times than we want them to plot. We'll have to close them a few times. Just, a little heads up. We'll keep that in mind. But this does not really impact our end goal for this demo. And so the data set we're going to look at is going to have a date, it's going to have an opening price, a low for that day, a high for that day, and we're going to be predicting the high price. That's why we predicted, I highlighted that in green, the close, the adjusted close, and the total volume of the transactions. So without further ado, let's get right into it. Okay, so let's get started with the Bitcoin regression demo. So the file we want to look at is actually in demo files. It's entitled Bitcoin Demo All.csv. There are two different demo files, but this one's a little smaller, which is not maybe the best name, but that's okay. So Bitcoin Demo All.csv. And when we do a regression in Neurales, we have to actually specify the mode we are in. So we put dash in mode, we put RAG for regression. By default, it's classification, which is CLF, but we don't need to enter that in if we're doing classification because again, it's a default argument. So we're going to be doing manifold plots, and I'll show you what I mean by them being a little bit buggy. We're also going to do something different that we didn't do last time. We're going to do anomaly detection on the data. And remember, if you're not sure what these do, just you can always look at the documentation. We're actually going to run through it in real time now, though. So give it a second to load in the data. It's not too big. It's a little over 300 samples, if I remember correctly, for this data set. Okay, so we have it loaded in. So remember that in Neurales, it doesn't like when your data is in non-numeric format, and the dates are unfortunately not the right formats because they have dashes, no special characters, nothing other than just straight up whole numbers or decimals. So we're going to drop one column, and we're going to drop the date. Remember, it's case sensitive, so we have to make sure we spell it just right. Okay, so now we have a new data set with that column dropped. Okay, so now let's predict. Remember, we want to predict the high. Okay, so let's do the standard scale this time, actually. And which manifold plot do we want to see? So last time we did t-SNE in 2 dimensions. So this time we're going to do isomap in 3 dimensions. Let's see what that looks like. Oh, then one more thing I should mention. So here, because manifold plotting really does take a lot of time, what Neurales will do, it actually will plot only the first 250 samples. The idea is that hopefully those first 250 are roughly representative of the data set as a whole. It may not be, it's something to keep in mind. But because it's so computationally intense, it may take a long time for the plot to happen. So you have the option to, if you want to plot the whole data set, you just got to put it in Y if you want the whole data set. If you don't want the whole data set, you can just put an N. So this will only plot the first 250. And just give it a second to load up, and there we go. We see the 3-dimensional plot of the isomap. And we have to close it a few times because we have the little bug that I talked about in the first part of this presentation. And so here's a nice little plot. And so unlike with classification, you get color codes because each set of features is grouped into its corresponding class. But here, we just kind of want to see the data set represented as, a lower dimensional manifold. And we're not going to get into the technicalities of that in this presentation, but I'll make a separate video exactly with the interpretations of these plots for regression, and a little bit more detail for classification as well. Okay, so remember that Neurales uses by default random forest, and random forest algorithm can be used for either classification or regression. So let's pick the max depth of the trees. Let's just pick 8 to start with. And how many trees do we want? Let's just say 200 trees. Usually, between 100 and 200 trees is a pretty good starting point. Let's just hit run. Okay, great. So we didn't see the loss actually because we are also doing anomaly detection. So what this does is actually we'll scan through the entire data set, and it will tell you exactly which data point is anomalous, and it'll just put anomaly next to that data sample. So you see here we have this algorithm found 16 anomalies, and if you want to know exactly what algorithm we use, we actually used the isolation forest algorithm to find these anomalies, and we will probably link maybe a description somewhere to people who want to learn more about the isolation forest. But see, here we found 16 anomalies in the data set. So remember that it's a little harder to interpret the results of the regression because we have the loss is mean square error loss, and numbers can be a bit large, they can be a bit small, and it's not always exactly obvious if that's good or bad. So let's just predict some things. So let's predict some data points. So the way you do that is you go into the debugger, you do predict model, and then you put X, and then you put colon, let's say the first 5 data points. Okay, so our first 5 data points, remember we're predicting the high value of Bitcoin for a given day for the first 5 days of 2019. Now let's see how that compares to the first 5. So you see here it wasn't too far off. So the first data point was 3,859 and 83 cents or 84 cents if you want to round, and the actual price was 3,850. And you can see that the data points are fairly similar. We could potentially do better, but that's part of machine learning. We have to find the right model for our data set. But that's essentially really all there is to the regression. You simply just put in your data set, and you pick a model, and you can just simply go into the debugger mode and sort of see exactly how predictive, how good are predictions your model makes. Let's just do one more. Let's predict maybe the first 15. So to do that, you're just going to do. Let me scroll down a little bit so you can see model. Let's just say first 15. So we do dot 15, colon 15, and now we have the first 15. And if we want to see the actual first 15, we just want to do y first 15, and we see here exactly how well it compares. And you see there it's definitely a little off, but not horribly off. So our model is okay, but we want to improve upon that. Now, let's say you want to predict the last 5. So then we do model X. We're going to do actually -5 colon. And there we go. These are our last 5 predictions. And we're going to do the same thing for the y. So we're going to do -5. Just if I can type. Okay, so here are our last 5, and you see, this for the first prediction for the last 5, it actually was pretty spot on. I actually got it right within the dollar. So that is that's pretty good. So that is going to wrap up this demonstration. So I hope you guys enjoyed, an introduction to how we do regression in Neurales. Feel free to leave any comments or questions, anywhere, on our YouTube channel, or just, contact us directly. And we'll see you guys in the next demonstration. Thanks for watching.